let's take a look at reversing the similarity now. So it's not as common as a straightforward similarity question, but we can sometimes be asked if we are given similar areas to work our way back to work out the lengths of missing sides. And let's take a look at this example here. So it says the two objects below are mathematically similar and have dimensions as shown. So the area of the smaller shape is 4 square centimeters and has one of its lengths 3.5 centimeters. The area of the bigger shape is 36 square centimeters, and I want to find out the value of x. So straight away, I can't work out my scale factor, my normal linear scale factor, because I don't have two corresponding sides. What I do have though are two corresponding areas. So straight away, this is going to be the new shape and this is going to be the old shape. New shape because that's where the variable that I'm working out is. So I've got my two corresponding areas. So straight away, I can work out my area scale factor. So area scale factor is going to be 36 new over old. So it's 36 over 4, which gives us 9. So that's what I multiply my areas by in order to get the enlargement to happen. So in order for us to work out the linear scale factor, I have to now do the opposite of what we did when we found the area scale factor, and that would just be to square root it. So I can say that my scale factor is just going to be the square root of 9, which is 3. So therefore, x is just going to be 3.5 times 3. So 3.5 times 3 is going to give me 10.5. So it's going to be 10.5 centimeters. Okay. Let's look at example 8. A waste paper bin and its smaller version with our dimensions are shown below. So this time we have a big volume of 40 litres and a height of 45 centimetres, a smaller volume of 5 litres, and I want to work out the height. So this is the new shape, this is the old shape. So for this I can say that my volume scale factor, because that's what I have that's corresponding now, I have corresponding similar volumes. So my volume scale factor is going to be new over old, which will be 5 over 40, which is going to simplify down to give me an eighth. It's always important because this could come up in a non-calculator question. So volume scale factor is 5 over 40, which gives us an eighth. Because I want to work out the similar lengths, I want to do the opposite of what I would do to get the volume scale factor and find the cubed root of it. So the scale factor is going to be the cubed root of an eighth. And if you ever want to cube root a fraction, you cube root at the top, cube root at the bottom, so that would just give us a half. You can test it on your calculator just to make sure that it works out. Okay? So my scale factor is going to be a half, so I can say that the height h is going to be 45 multiplied by a half, which is 22.5 centimeters. Okay?